Welcome to all. This is part 1, lecture number 13. What I am covering today is resolution of a force along two mutually perpendicular inclined planes. Now, I will give some explanation. Remember, you have to, those who are preparing the notes from going to the class, if you want to learn everything, you have to write everything in detail by slowly watching the class. First, what is going on, I will tell first. Maximum times, almost say more than 95, not 95, almost 98% times. In structural engineering, we want resolution in horizontal and vertical directions. I will use today red color for that one. Only for today, red color. See, horizontal and vertical. I will call horizontal as XX, vertical as YY. So you can either call XX axis, YY axis, but once we enter strength of materials and structural analysis, we will not be using the word using XX and YY. We will use the pure technical horizontal, vertical. Therefore, in all such cases, whenever an inclined force is given or acting, you have to resolve the force into components along XX and YY. See, if I told you like this, X component, I'll put here, or if the force is P, force along X, force along Y, this is already thoroughly covered in the last class. I told something, for easy calculation or solving and to avoid confusion, preferably mark the angle with the nearest XX, say theta. Then you need not bother. X component is cos, Y component is sine, or horizontal cos, vertical sine. This already I told. Now, I told 98%. Still 2% is there. Okay, I'll remove the board now. Remove the board means not remove the board, remove the writing on the board. Remove the board means how I can remove it. Okay. Now, some will ask, sir, what is that 2%? Rarely, for example, in engineering mechanics, in case of friction problem, when a body is moving or tends to move along an inclined plane, see, this way, a body, this way body, or this way, either it may be pulled up or pushed down, or it may be pulled up or it may slide down, whatever is there. In such cases, if you consider XX and YY axis here also XX, YY is there, no problem, answer will come. But sometimes it gives unnecessary more calculation. That is, it becomes lengthy. Solution becomes faster if you consider instead of XX, YY here, see, if you consider, I'll use a color change now, I'll use green color. See, instead of XX, YY, usually we consider what? See, this red is only for today. Usually you take YY, XX like this. Suppose you want this plane, some solution. What you can do is, you can take, see, along this plane XX, and perpendicular to that plane YY. Or along this plane, you can take this as XX, perpendicular is YY. Then solution becomes faster. Advantage is there. Okay, now, this XX is not this XX. Or if confusion is there, you can do one thing. Sometimes people will tell, sorry, XX means, or we always take horizontal. Okay, no problem. You take X dash, Y dash, Y dash. So other plane, X double dash, Y double dash, Y double dash. That way. Or see, same thing is turned. Or you can tell you bend your body and look this way. See, vertical, horizontal, that is easier. That is for friction problems. And in strength of materials, when you consider, this I told last time, when an element is given where stresses are given like this is called two-dimensional stressed element. Sometimes an inclined plane will be given for you. Not given. Some inclined plane you require what is the normal stress and shear stress. Then you have to resolve the stresses. You cannot resolve directly, you have to convert to forces. That will come in strength of materials. You have to resolve along in this direction or in this direction. So you can do one thing. You can imagine, just see, this is x dash x, or x only will do, and see, y dash, y dash. So therefore, you should know, you should not always by heart that measure the angle with always horizontal. That is, if x, y, y are horizontal, vertical. So still same principle, measure the angle or consider the angle with x dash, x dash. One case. Next, if you go to arches in structural analysis problems, see, when you got an arch here, when you take a section here, see, you require somewhere radial shear and normal thrust. Radial shear, normal thrust. Then also, whatever forces are acting, you need one component along this direction and also this direction. That is resolution here or here or here of a given force into two mutually perpendicular, not horizontal vertical plane, inclined planes. See, once one plane is horizontal, other becomes vertical, natural. But the moment one plane becomes inclined, its perpendicular will also be inclined. Okay, therefore, that is what you are covering. Even furthermore application is there. Right now is not the time. When in the subject later, when we go for strength of materials, etc., then we will consider it. Okay, now I will remove this one. I will clean this one, remove this one. See? This I will remove and tell you the principle. How to resolve or what is the principle. Then I will take master question. See, question means master question. So that very thoroughly you understand everything. Master question. Question will be dictated in the class. Sketch will be given for you. Some force system is there. I will tell you what is the question later. Now, this after I explain little portion here now, for this question, these components I will not calculate in the class. You know yesterday, last class what happened? Some small calculation mistake. So, and here, there is a check also is there in the end. If I make one calculation mistake, check will not be satisfied. So, when check is there, I should be absolutely sure that no calculation mistake. So, what I will do is, I will first explain to you about resolution, make a note, then somewhere here, I will write the result. I will take my own time. What I will do? Not prepare and write. I will take my calculator. See, that's all I will do. Like in the offline class, all same thing. I don't go inside and write and come. I will take my calculator, observe here, come here. And then I can imagine, I don't require writing also. See, to resolve this one, I don't have to write, mark the axis, angle, theta, nothing required for me. Look at here, see, for this one. If you want along this way and this way, see, I can tell directly, see, directly here. Here, directly here. I can make out. Angle, there is no confusion for me. Fortunately, I got good mathematical grip. So, what I will do is somewhere here, first I will write the result. So that when I show the calculation, I can see what is the answer there, write it. You can check it. Therefore, first I will explain to you little concept now. Then I will write the answer. Slowly I will calculate. I will take my own time. See. Okay. Not too clean required. Remember, once again I will tell you, if you want to resolve along x and y, when x and y are horizontal and vertical, That is a huge 98% case. That is always comes this way, xx, yy, xx horizontal, yy. I told always measure the angle with nearest xx, and you see that angle is less than 90 degrees. This I will explain later. More than 90, what happens, what mistake will come, I will explain later. And then you can close your eyes, x component is cos, y component is sin. This I told already, not once, I think most probably I am telling it for 30th or 40th time. Okay. Now, by chance, see, there is an inclined plane here. See, I write here, there is an inclined plane. Inclined plane. Our purpose is to resolve the forces, any force, in two mutually perpendicular directions. One of them is along the inclined plane. So what I will do, you write here, inclined plane. One of them is along this inclined plane. See, this way. I will tell x, yeah, I can call still xx. Okay, I will call x dash. Okay. You can call xx only because, and other one perpendicular to it. That's very, very important. Perpendicular, it say y dash. Then what to do is consider the angle made by the force to be resolved, with, I told, nearest x dash. That is again same condition, no angle more than 90 degrees. Then directly, without bothering, component along x dash is cos, along y dash is sin. Let it be this way, or it can be even like this also. See, then what to do? Then take this axis here. If both are there, you call x double dash. I think I have gone beyond the board, I think, most probably. See, sometimes it happens. No problem. X double dash, you can take y double dash if you want. Or you can take y dash, y only. This way. See, this is your x dash. This way, if you do it, here also, measure the angle with x double dash, and then nearest angle, which is less than 90. Nearest angle is always less than 90. Somebody will be laughing. Then x will be cos, y will be sin. Remember. Now, that's all in the class I will tell. In the notes, what I will do is I will tell one by one force. See, this is there in the class. Individually, I will tell. See, inclined plane is like this here. I will tell if a force is this way, what happens. If you want to resolve along usually xx, yy, what happens, or this inclined plane, what happens. Horizontal force is there. If you resolve usual, what is the difference, or what happens, or if you resolve along this one, or any random incline. This all I explain. Once for this sketch, once for this sketch. In the notes I will write, but here you can make out. So now I will go to the master example. What all I tell, correctly listen. You don't by heart. Plane is like this. Plane can be like this also. Here I will solve one question on this one. In the notes I will write this question I will write. Extra I will write when the plane is this way, and there I will write the notes already explained in the class. Practice and get the answer. Okay, now question I will tell. Question I will tell later. I will do one thing now. I will now first prepare the answer so that no error is there, because lastly there is going to be a check. Now we will start the question. Very slowly I am explaining. And regarding how to find the angle Here, I will explain each and everything and write the answer. Those who want to learn, it is their responsibility to write whatever I told. Even in the notes also I will do one thing. I will mark, suppose I got some angle 30 degrees here. I will write, this is 30 degrees. I will tell, because there also, I can't write how I got, see this is 70, this is 20, that all in the notes I can't write. So I will tell how the angles came, I will round up the notes and tell, go to the class, thoroughly go through, and then you make a note. Sometimes it happens that everything I can tell, see, this way, how I can tell in the notes. Therefore, even if you use the notes, lot of explanation will be there, everything will be covered. But some of the concept, at that time, you can stop the notes and come to the class. Okay, start. Question, master question, dictated. There is an inclined plane AB. See, A to B full, AB. Mine is AB. Starting at A, ending at B. Which is inclined at, see, this is horizontal surface, which is inclined at 30 degree with horizontal. Maybe one inclined plane. Forces are acting on that one as shown. Make a note. 140 is vertically down. 250 is pure horizontal. 180 is perpendicular to the plane. I am covering each and everything. 150 is along the plane. This 200 is randomly inclined at 20 degree with the plane, or as shown. For all these forces, resolve and get the components. Our main purpose is in the question, see, in the question, our main purpose is get the components in two mutually perpendicular axes. One of them is along the plane, other is perpendicular to the plane. That is, in the question is, if this is AB, we want components resolve one along the plane. See the color here, green color. Other perpendicular to the plane. I may call this as y dash later, x dash later. This is a question. This is perpendicular. But someone will tell, sir, you resolved horizontal vertical. Wait 1 minute. This is a main question. Okay, over. Now, write a note. We will do 2-time resolution. First, what we will do is, we will not resolve along AB and perpendicular. Make a note. You should write it. First, we will go to our traditional, right there. Our traditional, that is XXYY. I use red color, where XX is horizontal, YY is vertical. Somebody may ask, sir, in the question you told along the plane and perpendicular to the plane, why you are doing? This is only for understanding. So our real question is, this is the real question. Our real answer. Our real question is resolution along the plane and perpendicular. That I will take second half. So first half is repetition of what you done last time, only for practice purpose, right here. This is only for practice and later to compare. Okay, first do one thing. So therefore, right, first right here, first red color, first resolution in horizontal and vertical directions. That is XX and YY. Only for practice. Right here, XX is like this, YY is like this. Right this way, perpendicular, understood. This is horizontal, then this is vertical, over. First you write, remember, only for practice purpose. Our real question will start after this one. Don't skip this one now, start one by one. Now, one note you have to make. See, 140 Newton, first right here. Consider 140 Newton at C. Okay, at C. It is purely vertical. Therefore, no resolution. See, later, direct 140 I wrote here. Right mark means direct. Or in case you resolve, somebody will be laughing. Why? 140 is purely vertical. It makes angle of 90 degree with horizontal. So horizontal component is 140 cos 90 0. Vertical is 140 sin 90 is 1. And again I will become a laughing person. I will be a reason for someone to laugh. Pure vertical given, he is resolving with taking angle theta 90 degrees. He does not know anything. They will tell, I know, not that way. So when you want to resolve along xx and yy, if any force is directly given along xx, yy, no resolution, direct answer, right here. Directly over. Don't write here. No resolution. So later at C, directly 140 entered. Same way, see here. Consider 250 Newton force. Newton force I won't write, at D, right here. This is purely horizontal. Angle with horizontal is 0 degrees. So cos 0 is 1. Again, if you start resolving horizontal force, if you want to resolve in horizontal and vertical component, vertical will not come, only horizontal. So this also direct entry, see here, at D, directly 250, over. Now, these two are over. This I to, first of all, this much I need not explain. Okay, now, start one by one. This I am not removing. Consider one information I will give you. To prepare these two answers, including some summation I have done. See, finally, checking is still pending. I will tell honestly with you. I summed up the answers. Finally, if you replace by a single force here and a single force here, both should come same. My guarantee, it will come. Otherwise, there is no meaning for structural engineering. I calculate that one. Then, finding resultant is not a big issue. Just squares and root. I have not done because I got confidence. So, I will tell honestly, this all the result to write neatly, it took around 10 minutes to me. Because why? Actually, randomly if you ask, it will take only 2 minutes for me. I don't have to think, but here not that way. In the light, sometimes 8 will look like 9, I should be careful. So carefully I have done it. I do not want any mistake. So okay, start. Consider 180 Newton force. Newton force you write, force at E. See now. The force, see now, see correct, clear. It is you should write something. What all I am telling you are right. This 180 Newton force is perpendicular to the plane. Okay, now we want a component along xx and yy. Therefore, see what you do is, it is not along xx, yy. Therefore, what you do is, see, 180 Newton is here. If I mark xx here, and yy here, then 180 Newton force, see, it is actually acting this way. It is perpendicular to this plane. See here, it is this one. No, black, not color, black color only. See here, it is this way. It is this way. But we want component along xx, yy. So we want this angle for resolving. See here, this is perpendicular to this line. If this line makes 30 degree with horizontal, means mathematical rule, if this line makes 30 degree with horizontal, its perpendicular will make 90 minus 30, 60 degree with horizontal. Or, see, correct, clear, see, actually not required, see, the plane is here, see, once again, plane is here. This is 30 degrees. If that is 30, this is 60 degrees. If that is 60 degrees, this is perpendicular to this line, this will again become 30 degrees. Then this will become 60 degrees. See, 30, 60, this is perpendicular to this line. So if it is 60, this is 90, 30, since it is perpendicular, 60. You make a note. So now I remove everything. I told refer to the class. Okay. This is 60 degrees, this angle. 60 degrees. How I told? Or direct answer. Why? There's a mathematical rule. If a line makes an angle theta with one direction, its perpendicular makes 90 minus theta with the same direction. Now, if I resolve equal to this point is which point? E. Okay, this point is E. Anywhere you can write, see this way. A horizontally right component and color, I will put this red color. Horizontally right component and see here, see, right component and down component. And down component. Horizontal component is 180 cos 60. This is 180 into sin 60. 180 cos 60 is 90 Newton. I calculated there. 180 sin 60 is 155.885. This is to save the time. 885 Newton. Therefore, now this force is replaced by one. See here. This force, you can mark wherever you want. This force is replaced by one force acting right side of how much? 90 Newton. I written upper side because the force is coming from upper side. 90 Newton and one more force vertically down of 155.885 Newton. Okay, that also over. If difficulty is there, you go through the class again and again. That's all. Now, next. Consider 150 Newton force. See, it is actually this way. Somewhere here. At which point? At F. This is the point F. 150 is like this. Oh, you can tell. See, with the horizontal, this line makes 30 degrees. Therefore, with the horizontal here, it will also make same 30 degrees. Over. Nothing required. Therefore, if you resolve now, one right side, one upwards. So, equal to a right side component and upward component. Right side component is 150 into cos 30. Upward is 150 into sin 30. This is undoubtedly 75. Why? Sin 30 is half. This will be 129.904 Newton. Therefore, this 150 Newton, see when you consider x and y, these are inclined forces. This inclined force will have a component like this. I entered here 129.904 here, 75 here. Okay, that also over. Now, last force. I removed xx actually. Okay, no problem. Okay, remember xx, y already here also. Okay. Lastly, consider 200 Newton at G. See, this line is here. See correctly now. This line is here. At the point G, 200 Newton is making an angle of, see, this is 200 Newton. It is making an angle of 20 degrees with this axis. And this line with horizontal makes 30 degrees. Or if this is 30, if I draw one horizontal line here, if this is 30, this is also 30 degrees. Therefore, if you consider 200 Newton here, 200 Newton, to which point? 200 Newton, put here, same way, at the point G. At the point G, if you consider that 200 Newton force, it makes an angle of, see here, this is 20, this is 30, we want this angle, it makes horizontal, 30 plus 20 is 50 degrees. Now if you resolve one component like this, one component like this, are equal to horizontal component of 200 cos 50, vertical downwards of 200 sin 50. 200 cos 50 is 128.558 Newton. This is 153.209 Newton. Therefore, this 200 Newton force I replace by these two forces. See here, down of 153.209, left side of 128.558. So, this is right here. this is the result, or right here, this is components along which one? Xx and yy, where xx is horizontal. When xx is horizontal, no one should y okay, really, y is vertical. Somebody will be laughing. Mutually perpendicular, xx horizontal. He is telling y vertical. What, we are not knowing that much, but nobody will tell in front of me. They know, if they tell that in front of me, I will show them where is the limitation. Okay, over. Now, I am going for the real concept. That is, what is the real requirement? Okay, now write a note here. It's all over. Make a note. This is the result we got when xx, yy are like this. This is only for practice purpose. It is not today's agenda, or today's class title is what? See the title there? Resolution of a force into two mutually perpendicular inclined directions or inclined axis. Something like that will be there. Means now today's class real concept, or actually you can write here, today's class starts now. Then someone will tell, what about that one? It is not that way. What I told, what I am covering today, it starts now. Okay, start. Resolution, see, I will use the color now. Second part, resolution along two mutually perpendicular axes. One of them is along the plane, and other is perpendicular to which plane? To the plane AB. Okay, along the plane AB, another is perpendicular to plane AB. Or you can write, one of them is along the inclined plane, other is perpendicular inclined plane. Along the plane you call, to understand, x dash. Perpendicular you call y dash. Make this note first. I am rubbing now. I want space. Make this note. There. See correctly. Therefore, now see, if I take A here, B here, anywhere you can mark. I write here. If I take A here and B here, this is your xx plane or x dash, perpendicular to that one is your y dash. Okay. First write a note. Okay, start. Now, one by one. First, consider 140 Newton force. See here. 140 Newton force is purely vertical. See, right here, it is vertical. Through the point C, at C. It is like this. Now, we want to resolve this force, one component along this line, other this line. So, we want, see, your plane goes this way. I told 1,000 times for you. This is your x dash. Other you can see y dash there. Okay, one sufficient. We always want the angle made with the nearest this angle we want. What is the force here? This is 140 Newton. This angle will be, see again, see here, I am wasting my time. If this is 30 degrees, this will be 60 degrees. Very clear. Therefore, now, see, this is pure vertical. If you resolve now, see here, I will mark here now, one component will be like this, other component will be like this. See here, one component will be like this, other like this, then only it will come. See, this is one component. See, when you take a force here, one component like this, it can't be that way. By mistake, if you put this way and this way, the force will go that side. See, this is one component like this, one component like this, equal to, see, one component like this, other component like this. This is your x-x direction, I already told. This is 140, this is 140. Now you don't have to see, angle is measured with the x dash x dash. So x dash is cos, y dash is sine. This thoroughly I told for you. Cos 60, sine 60. This I explained 1000 times for you. Okay, right? 140 cos, this one is 70 Newton. This is 121.244 Newton. Therefore, right here, this vertical force here, which is actually perpendicular, but for this plane, it is inclined. You can replace by one force like this of 70 Newton, other like this of 121.244 Newton. Again I told, difficulty means go through the class again and again, that's all. Again and again go through it. Okay, now start. That's the best thing to do. Consider 200 Newton force. 200 Newton force. See here. This is your inclined plane. This itself is what? Is your x dash. 200 Newton force is acting here where? At the point D like this. How much? 250 Newton. 250 Newton. We want angle made with nearest horizontal. If this is, when this is 30 degrees, this also is 30 degrees. Okay. Now, if I resolve here, see now, one component will go this way, other will come perpendicular to this one, this way. Then only resultant will go this way, see. Now, this you should practice. So this will be 250 into cos 30. Why? As long as you take angle with the x dash, that is cos, other is sine. Now I won't tell you again and again, repeatedly. Oh sorry, I should write one thing, not here. I write somewhere outside, not here. See, or equal to, okay, through the point D. See, where is the force? I resolved here, correct? Okay, I resolved here. See, one this way, one this way. So one force this way, one force this way. This is 250 into cos 30. This is 250 into sin 30. 250 cos 30 is 216.506 Newton. This is 125 Newton. You don't have to worry. Therefore, see here, this force this way, see here, has got a component, one this way, one this way. You can see here only, see, this way, then only. So this along the x component is, how much I got? Where is it? 216.506 Newton, and the perpendicular to that one is 125 Newton. This force also over, the force at E. Okay. Now, come next force. Over, nothing much. Okay. Consider 180 Newton force at E. See, our x inclined line is here. This is your x dash, which is that one? This line only. This force is at E perpendicular to it. How much? 180 Newton. Oh, that is, it is directly acting along your y dash. Therefore, no resolution. There is no component here because theta is 90 degrees or y that way. This is equivalent to your vertical, equivalent to horizontal. So directly vertical, directly perpendicular. So direct answer of 180 Newton. No resolution, right here. No resolution, direct entry. Okay, now, last but one. Over. Consider 150 Newton at F. Sorry. See, your plane is like this. Your x dash plane. Your 150 Newton is like this. Oh, right here. This also is directly along x dash x dash. So no component this way, only component this also direct entry. Direct. Here. Direct answer. No component here. Okay, now last force. See, if confusion is there, again go through. Lastly, important one. Lastly, 200 Newton at B. Be careful now. See, this is the point G. Okay, G. This is the point G. 200 Newton. See, this is your x dash line. See, correct? Clear. This is your x dash line. 200 Newton force is here. Oh, they told it is making angle of 20 degrees with x dash. Oh, thank you very much. See, over. Nearest angle is 20 only, directly. Because why? But see, when you last time what you have taken, when you took xx, you took what? 30 plus 20. Okay, now, therefore, this, we have to write here, okay, x dash equal to, see here, one component this way, one component like this. So it has got at the point G, one component like this, one component like this. This is 200, angle is 20 degree with x dash. So this is cos 20, this is sin 20, equal to. Why calculate? This is cos 20 is 187.939 Newton. This is 68.404 Newton. Okay. Therefore, now later see here, one component like see here, you put it this way, one this way, one this way. I entered here, the 2 components. Open. This is the result of components along and perpendicular to inclined plane AB. You don't have to write x dash y dash like that. So this is a result for components along the inclined plane, or you can tell what we called it as what? Along is x dash, perpendicular is y dash. You can make a note. Check the camera first. Hope it is not outside. Not outside. Okay. Question is completely over. Now I will see how much time is left out. If little time is there, one trick I will show you. 40 minutes, okay. No problem, I can manage. Now, see, everything over. This full I am removing now. Everything I am removing. Nothing required. How to check the answer? Now do one thing. Now check. I use a black color. Definitely ink I have to put. Therefore, I rub the board. I will do one thing. I write something because the board has to be cleaned. Wait, I will pause the video for a little time and then write once again. Because little clean I want to make, checking. Now, question is over. Just curiosity or to get the grip. See, sometimes when you get the grip, when you apply a check, if it passes, how happy you will be. Therefore, check. See, check. What you can do is, see now, I will not write everything now because it's a check. See correctly what I am telling. See the first one. See this one. Result here. See this one, first one. I put arrow mark here. That is, when we resolved along x-axis, you write here, when we resolved along x-axis and y-y. Right here. Find algebraic sum of all the components in x direction. See, 250, see here, 140 is vertical, leave it. 250 right, 90 right, 129.904 also right, but 128.558 left. So if you take right side as positive, plus 250, plus 90, plus 129.904, minus 128.558, that will come net, I will call sigma fx will come, I wrote it the answer there, 341.346. 341.346 plus will come, therefore that much right side. And sigma fy will come, see, I will do one thing now, majority are down, so, or okay, take upward positive. Okay, by upward positive. When majority are down, take downward positive only. See, down or you, by this time, you can make out that much. Down 140, down 155.885, up 75, down 153.209. So, 140, 155.885 and 153.209, add these three downward, remove the 75, subtract 75, it will come down. So sigma fy will come 374 point. This only check, those who want can do it. 094 Newton down. Now do one thing. If you mark any point here where line of action passes, don't worry about line of action. One force this way, sigma fx equal to 341.346 Newton, and sigma fy is down. Sigma fy is down equal to 374.094 Newton. Now resultant, I use black color. Its resultant will be, see, this is the resultant for the complete force system. Resultant R equal to root of sigma fx square plus sigma fy square. You show the calculation. Honestly, I will tell, I have not calculated because I got confidence. See, I got confidence. It will be 341.34 because why? Horizontal vertical, calculate is not on. 341.346 square plus 374.094 square equal to root answer 506.422 Newton. 506.422 Newton. Angles all not required, leave it, angle not required. Now, this is for that one. Now come to this one. That is right here. When we did the other resolution, that is one along x dash here, other is perpendicular to that one, y dash, then your sigma of f x dash equal to, see here, you take right side positive, minus 70 plus 216.506 plus 150 minus 187.939, it will come plus only, it will come 108.567. That much work you do it. 106 point, at least 108. That much if you can't do me, don't check it. 108.567. 567 Newton. How? It will be like this. This way. And your sigma fy dash will be, see, this way, acting perpendicular in the other direction. 121.244, 125, 180 and 68.404. All are correct? It will be correct. 494.648. 494 point, correct answer is 494.648 Newton. 648 Newton, it is this way. Therefore, right now, if you mark a point here, one force like this, one force this way, sigma fx dash equal to 108.567 567 Newton. Other is perpendicular to it, sigma Fy dash equal to 494.648 Newton. The resultant will come this way. Resultant will come this way, equal to, right there, remove that one, square root of, now this is horizontal, this is vertical, sigma Fx dash square plus sigma Fy dash square. I should write neatly. I don't want to spoil this. So far, so neatly written. Sigma Fx dash square plus sigma Fy dash square root equal to answer. Now is the testing time for my concept. Because whether you replace that way or this way, resultant has to come same. Otherwise, this today will be the last class for me, teaching. Okay, now see, hand is trembling, nothing is happening. 108.567 square plus 494.648 square equal to root, answer, I had put equal now. I have no tension or worry. By chance, if answer, honestly I will tell you, I have not calculated. If answer is not tallying, only possibility is somewhere calculation mistake. I think I have done very, very carefully. Therefore, with full faith in my calculation, I will put equal. 506.422. I am not seeing that answer. 506.422 Newton. Same answer. Over. This is one check. Now I will tell you one super check. You try it. Super check. See, this is one check. Super check. I will tell you super check for you. First I have to finish. Super check. First time you have got one force, one horizontal force this way. See, this you have to do it. First time when you took xx and yy this way, you got a horizontal force this way of 341.346 Newton and a vertical force of 374.094 Newton. Now do one thing. These two forces you resolve along x dash and y dash. X dash and x dash and y dash. Two forces are there. You have to find components and add it. My guarantee, answer will come. Answer will come. My guarantee. 494.648, and why should I bother to calculate? This will come. Only those who are serious can do it. 108.567. Oh, same answer. Or, right, when you resolved along x dash and y dash, your answer came one force like this. How much you got? 108.567 Newton. Other you got this way of 494.648 Newton. This now, okay, I remove this one now. Now you do one thing. These two forces you resolve along xx and yy. Resolve. You will get the answer. I'll check it fast. That's all. You will get the answer. 374 point. You have two components are there. You have to resolve both of them. See, horizontal, vertical. Then total you have to get it. 374.094 Newton. And you will get 341.346 Newton. That is, both are same. Once we resolved along horizontal, vertical, and then we solved by considering inclined plane and perpendicular, because whatever you do, finally solution for a problem will remain same. Okay, hope everything is clear. thoroughly go through. Next class will be, I don't know, remember, I have to see what is next class, I have to decide now. I will let you know in the next class. Actually, I think moment I am going most.